Sid, we're live.
We are?
We're live.
You put it on too soon.
Put your outfit on.
Aha. Is that half a point?
We've got one or two people in here right now.
There we go.
There we
Look apart
go.
now.
Now, where's the hat?
I forgot the Grinch hat.
Oh.
There we go.
Sid.
This right here's padding comes in all shapes and sizes. This was really nice padding.
Sid just upgraded to Windows 11, everybody.
Ubuntu 18.04 LTS, 64-bit.
All right. So if you're just joining us, of course, you can ask Sid anything while he is doing tests on the 12 kilowatt right now. And you can, of course, see our studio off into the right there, area there. And then Sid's off here on the left, doing some tests on the 12 kilowatt right now. Staying busy. And...
Want to touch this to see if it's live?
Oh, yeah, go ahead. Rick asks if the 12K and the 6K will work in parallel.
Should, once I get it working. I gotta get back to work on that function, but what they should.
Yeah, so
Because it's a matter of percentage. So they're not concerned about size, it's percentage. So 50% of a 6K is 3 kilowatts, 50% of a 12K is 6 kilowatts. So they should work together as
Good.
long as they know what the percentage is.
hopefully that answers your question there, Rick. Let's see here. Let's see, it's Friday evening. It's about 5 o'clock, so everybody on the West Coast still isn't home from work. A little earlier, but that's fine. That's fine. I'm not wearing my GS shirt right now. It's too cold.
So that's L1. So right here should be, that's S1.
So what exactly are you doing there, Sid? What are you doing? What are you testing
I'm
here?
trying to figure out what leads what. This right here is L1, so we can mark this
Yeah.
one out.
So they did not label these for
They
us.
That's L1.
So right now what Sid's doing is he's trying to figure out which one is which so that we can actually set this up for a 48 volt inverter.
These two we don't need. You want to mark them?
Let's see. George says awesome. Or Rick.
Whatever.
How do you want to mark them?
These are the ones we don't want to use. These are the 36 volt tap.
Okay,
36.
well, we got a whole bunch of zip ties here. Do you want to just zip tie which ones we don't want to use? Like zip tie the red or
Sure.
something? I mean, if that works.
As long as they're marked. Because these right here are the one. This right here appears to be 2, and that's 3.
Alright.
Maybe 2, but I can't zip tie them together. That'll be very colorful. You can see how much power the variac can do.
Where did my side covers go? Right here.
I'll take these up, obviously, for any testing, but
Cut the slack off of those if you want.
yeah,
Okay.
it's artistic expression there. It's right here.
All different colors if you need them to mark whatever you want. We got 3 people in channel. Just Rick has asked a question. That's it so far.
Okay, well,
That's fine. Again, it's Friday. It's still early. The West Coast. Those guys out there are still at work. It's like 2 o'clock there.
they put that pad there, glued it down too. That's entertaining. There's that one, there's that one. Let's double check them again. So that's 120. I don't like using tingalometer to figure out if it's 120 volt. So we should have here, 14. This right here should be, it says 16, but it should be 0 unless they cross the wire. If they cross the wire between the pads, then I'd be yelling at it again.
What? How they tested this at the factory? How did they screw it up after?
Well, let's say over here we got the 14.7 I'm expecting. Measured the other one, it's saying 16. I don't know if that's low power or if it's an actual crossed wire, or because the other side of this one is back here. We get the proper 14 over here. So the taps are correct, but they shouldn't be connected together. Could just be meter capacitance. There's 1.5 there.
I don't see how. Yeah, I mean they tested it. So how did it was set right at the factory? So what changed?
Probably nothing. I'm just trying to figure
Okay.
out what I'm looking at. 12. We're probably dealing with capacitance between the wires, so it's probably fine.
The ones you cut off are for 60 volts, right? 60 and 24?
36 and 60.
36 and 60.
36
okay.
and 60 are those.
Yep, I got a lot to learn too, you guys, because this is a brand new transformer. It's easy to set right now, the 6 kilowatt ones, but we've got, look at all those strands. Look at that.
Yeah.
It's a lot of strands.
Here's the other side.
All right, Rick is asking me what I decided on the batteries. I've been messaging a couple of the Alibaba sellers and trying to get the best price, and it's a lot to think about. I'm not ready to purchase right now anyways. It's still a lot of money. But I will definitely start out with 16 batteries to start, just to test them, make sure they're working, they're genuine, etc., and then start ordering maybe once every couple of months or so until I've got the system up. From what I was reading, why am I behind the camera anyways?
Nobody knows.
I'm here. I'm right here. Let me move this up.
Penguin knows. You know?
Jeez, OP. I'm talking
Throw
behind the
apple
camera.
window.
I mean, this is really supposed to be your show today because you're up here, but
Well, I'm working.
sorry, technical difficulties here. I should probably get my shirt on now. Not everybody can see the basement, our wall of inverters and stuff. Yeah, wall of inverters.
Pulling all the boards out. So they all get
Yep,
clean.
we're pulling all the boards out so that we can get revision C boards in here. So let me get my shirt on.
Do you have bigger washers?
Like bigger as far as thicker.
Bigger in diameter, because these right here, they drilled the holes out in the lugs. These
No, those
bigger.
are, that's, I might, let me check. Here, these I need.
That's better, way better. I see. And use this wire. Use them to loop it around. So
Okay.
Big mess of it. You got 8 board in there.
Yes.
Is that for parts or for what?
I don't know. I think that was off of one of the original 5 when we replaced it.
Here's the thing.
Here.
I can pull the driver board off and reuse it. That's really big.
Too big?
Probably. I'll use this. I'll take the board.
Okay. You can
Is
have
that extra set of terminals?
that. I believe so.
Because I found another set of covers right here saying, how do we have those terminals?
That was, yeah, I think we did.
Okay.
It's been so long. It's been almost a year since we received this
Yeah.
prototype. Yeah. You can believe that.
I'll use this right
Okay,
here.
sounds good.
This goes in
Almost a
the.
year. I gotta get my shirt on.
What they'll turn this into is, you've seen the videos about the Grinch and Santa fighting it out when they see each other in the shopping mall.
Now, you haven't made any comments on this, and I've been waiting for you to make a comment.
Well, I've seen it. I've seen it.
Okay, okay. You just didn't say anything, so.
No, it
I
was
wasn't
small enough
sure.
I could ignore it.
Yeah, okay. If I get you one of these, it'll definitely have a penguin on it.
Okay, thank you.
They just happen to have this clip art handy. I'm like, oh, that's perfect. See how long it takes them to notice.
I noticed. This will either work or we'll short the transformer out.
Well,
So,
cool. Rick says he's gonna buy 2 100 kilowatt Tesla packs. 10,000 a piece, huh? 10,000 a piece.
yeah,
10 grand a piece.
Sounds about right.
All right, so I'm gonna fix my hair so I can look beautiful. What was the question?
You took the thing, they already had this bundled together. Where'd you put the jumper they had on it? They had these bundled together when they shipped it. Or they take that out before they, I thought I saw pictures and they had them bundled together.
Yes, they used these screws and nuts. That's all they used. This, Sid. All they did was use a screw in the nut, the main board screw in the nut. That's it.
Okay. Well, I put together nice. I get this wrapped around and so I get a nut on the end of it. Oh, I don't have nuts, so I gotta use this.
You need screw nut.
Oh, way better than this.
Yes, this is the one they used.
Way better than this mess.
Yeah. I just gotta find the other nut.
I see one.
Oh, okay, that's what I need. Oh, here's the other nut if you need another one.
I only need it if I lose this one.
Okay, set it right here for now. But yes, this is now running Windows 11.
In your imagination.
All right, hang on a sec. I gotta make sure I close this door. We'll get hit with a copyright claim because they're listening to their music up here.
Oh yeah.
Believe it or not.
Okay.
Okay.
See if I did this right. If I did it right, it won't make my clips flash or buzz loud.
Oh, everybody plug your ears.
Yeah, it's not that bad. So verify from here to there, we should have about 30. We'll see.
So if you're just joining us, if you're just joining us, it is testing the new 12K transformer. We already got a lot of good data on it already.
Yeah.
Let's see here. Ryan says, hey Ryan, do they sell MOSFETs for 48 volt, 10,000 watt power jack converters on Alibaba? I doubt it.
Alibaba.
Your best bet is to quite literally get a hold of Power Jack, because it's hard to find that stuff. Power Jack changes their stuff so much that it's hard to keep track of it anymore.
Yeah, I've given up. If it doesn't work, it probably wasn't meant to work.
Testing the 12 kilowatts a day, what wattage you are attempting to start? It's going to be low at first. So low at first, we don't want to just hit it just like that at 12 kilowatts. We don't even have any fans hooked up to it.
There's no main board or control board. I'm just testing the
Yeah,
transformer.
right now we're just testing the transformer. And then we'll get the main board in, got the new negative cable, or negative bus bar that is.
You have to fit that in there and get this thing tightened up. In case you're not
The day is still early, so the night.
I just got here an hour and a half ago.
Is Sid cold yet? It looks pretty warm.
Got insulation. 121. 29.8.
If Sid's laptop was downgraded to Windows 11, you then have to worry about the source code from the inverter firmware leaking onto the internet. LOL.
Yeah. Yep.
Yeah.
Windows, if you saw the amount of spyware in your computer that you can't disable, you would be shocked.
Let's not talk about that.
It is actually kind of fun to kind of disable all the user improvement and metrics that goes on, constantly send everything you do to Microsoft. One of them is tied to
Telemetry is what they call it.
Yes, it's all your personal information. One of them is tied to a system task. If you terminate it, the entire computer shuts down. That's how much they like their spyware.
Everything's on the internet these days.
Except our source code.
Yeah, that's true. Yeah, don't put that on the screen for everybody to see.
All 30,000 lines of it. I'd like to see you copy that down. Okay, that's good. Now I can take this off.
So again, if you're just joining us, Sid is testing the new transformer right now. We did some testing of our 6 kilowatt transformers as well, so that we could compare the first round with the second round. So that testing is done. Compared the prototype transformer to the pre-production transformer. Again, we still have time to make some changes. Even though this is pre-production, doesn't mean that's the final design. If Sid figures out that we need to change something or tweak something, we will. It's not going to drastically alter the inverter. It's not going to suddenly make us have to wait an extra 3 months. It's just a tweak. That's all it is. And that's right now where we're at right now is the tweak phase. So if Sid decides to change the core or strands or windings or shape or size or anything else like that, he can do that, and it's not going to be a big deal. So this is all part of the testing.
Yeah, it might be called a high efficiency core, but
yeah, we're already discovering. Sid's already discovering. You want to tell him what we discovered with that new core? Now this is not a negative. Like suddenly we can't use this. It's just that.
I'm trying to find the washer that you found. Put the nuts together.
Right here.
Oh, this right here. This will do.
Okay.
Oh, that's the other bolt. That'll work too. So basically, we haven't powered this up yet with an inverter with the main board, but I'm going to be curious to see what the no load consumption is. I'm guessing this high efficiency core is going to have double the no load current. And that's not exactly high efficiency.
So what's our goal for no load current? What's the goal?
Well, the other one runs about 0.7 amps at 48 volts, and I really, really like that. But we'll see. Because that one was wound wrong, which didn't help our tests, because there's a lot more wire on it than should have on it, which more wire equals more loss. So this one's wound right, but the core seems a lot lossier. The amperage measured is almost double at the same spec. So we might not be using this core any longer.
It's possible we'll go back to the old core, but the windings are correct.
The windings are correct on this one.
It's the core now that we're concerned about. But that's fine. We can go back to the older, cheaper core. It is cheaper, right?
Yeah, a fair amount cheaper. Or we may actually use this core size and actually make the core slightly larger because more increases weight, but we gotta make it work. DC. Unplug.
Gravely Down's got some code here for you to read.
Yeah, that's not a language I know.
Explain the DC voltage wires in the transformer. Like, how do you know which is which?
DC voltage wires in the transformer? Transformers run on AC.
Ryan might not understand what you're doing exactly.
Well, I'm just measuring the voltage. So put 120 in on the secondaries. I know what those are. Secondaries are both 120. And I just measure these out to see what the voltage is based on what I specified. So I rule these out because they were only at 7 volts, 7.5. And these are here at 14. So DC. DC now.
Are all 4 of these 6?
Hmm?
Is that going to be on one post?
Looks like the posts need to be a little taller. No, they'll be all right. The right post is much taller than the. That post looks so puny in there. Why'd they even do that?
I don't know. You'll definitely have to make another drawing.
Well, they just didn't bother buying. They must have got just one sample.
Well, I'm just saying you'll have to make another drawing for the production unit so that I can set them. There's a lot more to work with there.
Yeah, and it does get because there are only 3 taps technically instead of 4, and so there's a lot of losing a winding on the post and on the bolt just to get it out of the circuit.
That's a lot on one.
Yeah, it is. And the thing is, with the main board right here, the terminals there, we might be able to shorten these quite a bit. If I figured out, we might cut them in half.
That's a good idea. As
Way
long
much
as
more.
it's not going to hurt
Well, we
like
get
24 volts or 60 volts or something like that. The lower the voltage, the more posts they have to be on the main board, right?
Large. 24. We only need 1 post. Only 1 post for 24.
Yeah, on the main board, yeah.
We need 2 posts for 48, and 2 posts for 60.
Okay.
Yeah.
Well, as long as you draw it out like what you've got up there, then.
Yeah, I'll have to do something like that because it's a lot different.
Yep.
DC, let's do 50 amps with the power supply that can. Okay, 50 amps DC.
50 amps.
0.104, that's not much different. Oh, it's half. Aha. 0.104 measure P1, P2, 44. So the other one over there is 0.199.
Okay, yeah. So he
0.104.
said, sorry, I meant AC voltage wires. The ones you connect to the main board. So those would be, if it's a 48 volt inverter, it'd be like what, 28 volts, 26
I'm trying to keep it
volts?
closer to 30.
30?
The GS6s are 32, which starts to flat top a little easier than I like. I dropped this one because the ratio of the transformer core and it's a higher amperage, so more loss is going to start flattening the waves a lot sooner. Too low, and then we can't get high enough before we start running into efficiency issues.
What's the 6 kilowatt inverter efficiency? Mine seems very efficient.
So the 6 kilowatt inverter efficiency, we have not measured it. I'm glad it seems efficient. 12 kilowatt, that one right there, we measured 88 on the first one. Not a laboratory test, it's 88. This one should be in the low 90s, hopefully. Because already the primary is half the resistance. I really, really like that. So that's half the loss. And is that 1/4? Is this, the square is the wattage? So if it's 104, you don't check that again.
He said we know you're going to fix it. There you go.
I'm glad Elfrey's inverter is working. Yeah, we quite a journey on that one. We got some really nice customers. It's our job to take care of them.
Indeed we do.
Yeah, 104. So that is what it is, which means Ohm's law. Ohm's law. 104 millivolts at 50 amps equals 2.08 milliohms.
By the way, sneak peek at our new lid, what it's going to look like. Pretty much the final design. Sid hasn't, I don't think, seen it. I have to get a new
Well,
sticker.
we want to screw the LCD and show how much better it fits, because I got the hole smaller.
Oh
here.
yeah, I'll have to.
I reduced the size of the hole, so on the 6 case you see that big white backlight ring that's covered up on this. Now it looks really nice and tight.
Now it's flush, so all you see is screen. You don't see any circuit board underneath there, so that's nice.
Long overdue.
But the sticker, got a nice bigger sticker for a bigger inverter, and I have to have them make me a new sticker for this bottom part, because all I did was literally cut
it off.
Yeah, I just cut the solar panel off.
And we are hoping to get a clear sticker over there. Actually, it's not where the button, just the display part.
Yep.
Which does beg another interesting question. How many people we got on now? 13. It's about how many we've had before.
Yeah.
It's a major change, but I'm probably going to have to do it. The buttons, as you know, is up, down, enter. But if we put a printed label on it, the label has to work right side up and upside down, because we allow you to flip the screen, super easy in the software. But if the label has an arrow pointing up on this and down on this, and you rotate it, enter and up, switch sides, that's not going to work. So I thought about trying to keep legacy inverter, so we have two different, the ones that are already set up, keep the original buttons, or that they switch. So you want the label, it has to switch over. It might just be easiest to say, I know you work on Sharpie, but it can be redone. This would be up, enter, and down.
Or have the customer change it, be able to customize it themselves.
That's more mess in the code I want to avoid if I can.
Or do what we talked about earlier, just upgrade to the 4-inch display.
So my thoughts on that, 4 is for everything. So this goes into the supply stuff. So it's no secret. America is doing a pretty bad job making chips right now. Chinese, Asian chips, I can get those off the shelf by the millions. American chips, forget it. So the only reason we can still make inverters is because China has thousands of pieces of US chips stocked. Once those run out, we're screwed. So that's where I really hope I don't have to, but if I do, we gotta do what we gotta do to keep business. If I switch the GS processor to an Asian semiconductor processor out of necessity, which is also much cheaper and way more powerful, when I do that, I'll have to have a separate code branch anyway, so I might as well revamp the screen, go bigger screen, and redo all of it so it's completely separate on code base. I want to avoid doing that because then I have two separate code bases, two sets of bugs to work out, and so we do what we got to do.
Here first, folks. Not before the 12 kilowatt releases, obviously. But you heard it here first. Eventually, down the road.
Don't label the clear cover. Well, he does have a point there.
Yeah, that's true.
Update your web page to the progression of the units.
What do you mean by that?
I don't understand that one. I know the Kurd, or whatever, however you pronounce his pen name.
Kurd?
Yeah, I know the guy. Yeah, he got one of the pre-orders before he realized that the line specs were getting all messed up. So his inverter flat tops too soon. Yes, I'm aware of that. Forgot about it. Updating the web page for regression units. I'm forgetting about that. 12K inverter going away. We don't know, but it's going to be less than 150 pounds. I'm thinking, based on this here, it'll be around 120 pounds.
I'd say no more than 130.
Yeah, it's going to be below the 150 because if we go over that, we got to ship freight like everybody, like Ames and the rest of them.
Yep.
So, that is set. I got resistance. It's half the resistance. So if we run this at
Half the resistance
of that one.
Well, that's interesting.
Half. So in other words, if I take my 2 milliohms.
Well, that would make sense, wouldn't it? Because you got 50% more.
I do, but that alone wouldn't half the resistance. I have to go double to get half.
Oh, okay, yeah, that makes sense.
So the reason it's half is because I have 50% more, plus we have probably half the length of wire too, because we're running a much higher delta of the core on this one. If I do the math out here, it's how many turns versus how many turns. So 65 versus 96 is what they did. Yeah, they did 96 instead of 80. Gotta love it.
Yeah.
They got they passed everything I asked them to, but it's not quite what I had in mind. So 2 milliohms, if we're running 30 volts at 12 kilowatts at 14 with losses, at 30 equals 466 amps. At 2.08 milliohms equals 451 watts of heat.
450
Yes.
less watt.
450 watts total
Oh,
equals 450 watts.
make sure you explain what 450 means. Not that it's using 450 watts.
It's using 450 watts more than it's putting out, so that's 450 watts of heat generated. There goes the cat again. 14 kilowatt. So, oh come on. The frustrating part of using a spreadsheet, I'm trying to use a symbol. We're gonna see if they use the same dynamic.
They are the same. 2.7.
Do you want to check the one there and the other one? Because the resistances are so different. It's like they changed the width of the wire. So we're doing the same 466 amps at 3.98. Oops.
2.5
Yeah.
on the old one. This one looks smaller just looking at it.
It might be because it's higher resistance, significantly higher.
2.3.
2.3 and that's 2.5.
Yeah.
That's why those overheat sooner. They put thinner wire on it. 2.3 is the next size down. It's 2.5, 2.3, 2.0.
Well, that's what they did. I mean, it still does. It's 6 kilowatts and more, like it's supposed to, just not as big of a headroom
So
as
we
the
have
first set.
significant core difference between the two batches, and they use thinner wire on that one. No wonder they overheat sooner. And no, we did not beef up going off grid's inverter. He got one of the first ones.
Yeah.
Now I can yell at Anna properly, so we use a different size wire. Gotta love it. So, this one right here, the primary, running full blast, will lose 450 watts in heat.
Running at full blast.
Full blast.
What do you consider full blast though?
Nameplate, 12 kilowatts.
12,000 watts. It's losing 450.
450 watts
How
of
many
heat.
percent? What's the percentage of loss?
I have to calculate the secondary to get percentage.
Okay.
That one, running full blast, 864 watts of heat.
That makes sense.
800 watts of heat in the same winding. So this is half the loss. We might have a 15K inverter on our hands if we're not careful.
Good job, Sid. Good job, Sid. Now we just need to get that Windows 11 installed, and we'll have a 20 kilowatt inverter or 30 kilowatt.
Yes, you know what? That's what PowerJet runs. They run Windows. They make 30 kilowatt inverters that blow up at 10.
You got this little itty bitty transformer that runs 45 kilowatts.
It runs at 2 hertz too.
Yeah.
Let's see
what we got here. Hello, Sid. Oh, you can read it.
Ignore it. I've already been over that, and I've given up on that. Sometimes it's not worth arguing. Okay, 864, 450. Let's out the secondary and see what losses are.
We call it the universal transformer, and that's what we're doing. And this saves us a whole bunch of mess here. Admittedly, I didn't like the idea at first because it was more complicated.
Looks like an octopus.
However, we can order 100 of these without voltage, and then you order whatever voltage you want. I can set it here, done. Rather than, oh, sorry, we're out of 24 volt inverters, we'll have some in 3 months, or go through all the 48 volt inverters and only have 24 sitting on the shelf.
Then we have to upsell 24s for the rest of our life, every moment of it.
This allows us to have any voltage that we want, basically. And
you can actually, we don't recommend this because it's very risky, but it can technically, if you buy an inverter, you can reconfigure it in the field to any of the available voltages. You only have to void the software warranty, void the hardware warranty, change the CPU setting so it knows what voltage limits are, rewire the primaries, replace the cooling fans, and you're good to go. Any voltage is specified, 12, 24, 48, 36, 48 for that. This will be 24, 36, 48, 60 for this one. 60 on this will be special though, unfortunately.
So the fans are going to be your big downside. If you go from 24 to 48, you're going to need,
or 36.
Or 36, you're going to need different fans. We've got 24 volt fans and we have 48 volt fans. The 24s are compatible with
just 24.
24.
They're 24.
Yeah, because they don't work as low as 12 volts.
They're 20 to 40 volts,
Yep.
and our 48s are 36 to 72. They're
72.
72 or 75.
Yeah,
I
really
especially-
high.
I especially got them custom because those deltas, you can buy those $50 deltas, they will burn out. at 56 volts. I've had three of them do it.
Absolutely.
I actually lost the last two deltas that were in my inverter.
Oh, did you?
The last time I came up here, I was ready to leave and get out the way, and it wasn't working, and
I
The room
still have
smells
these really
terrible.
fast 24s if you want them for anything. These are the ones we had to order special because we didn't have any 24s at the time.
120 volts. Click. See what the drop is. Should be about the same. 2.6. Why is it moving? Should be stable.
For those who might be curious, this is what I use when I first power on an inverter, when I'm first starting it and it's running, it says running. I use this to check FETs, transformer, main board, because if something gets real hot real fast, then I know I've got a problem. So that's what I use this for.
2.56. Oh, way better on the secondary. This is going to be a pretty efficient inverter.
Oh, see, if this were a Windows machine, it'd be running a lot cooler.
Let's verify that 25 amp.
Because Windows is cooler.
Yeah, it don't work on my laptop right now.
Let's see.
1.43.
Ryan says Linux all the way, whatever. I'm going to have to put him in timeout here.
Delete all of his comments all the way back.
That was so weird. All he did was mute you as a joke for 300 seconds and it deleted all your comments. I don't understand that.
So my solar setup, well, it definitely doesn't meet code, that's for sure. And it's
Mine doesn't
hodgepodge
either.
together, but it works really well, and we live completely off grid. So it actually had the mains disconnected several years back. So there's no backup. I do have a generator. It's brand new in the box. It's been there for 2 years. I shouldn't have bought it, but when
Hey, well, you know.
when I did get it, we just about ran out of power twice. And like this is bad. I ordered a generator. It's brand new in the box. I need to go to
This thing's a little
the other
dusty.
side. Is that exactly half? 143, 256. Not quite. I will say I have 278. I get different numbers. 278. Problem with high currents. Resistance is a killer. Now we're back to 243. 222. 218. Goodness. Lips are warm.
Are they?
Yeah, I run 50 amps through them. Now we're 2.18. Oh, you can hit it with the gun?
I can feel useful here. All right, so let me tell you what those temperatures are.
I got my fingers on them. 2.14. Close to put it at 25.
It's between 77 and seems like it'd be warmer than that. Maybe some of it's
It's about
reflecting.
100.
Is it?
Has to be 1.14.
Some of it's reflecting. It must be.
0.14. That's closer. So let's measure the other side.
Yeah. Useless. Yeah.
So I do have about 12 kilowatts of solar, which when it's sunny, I have no idea what to do with all that power. It's just loads of power. I'm using 2 kilowatts. But when it's cloudy, that's the lifesaver. Because cloudy weather, at least in Ohio, if it's a bright cloudy, which is most of the year, except for December through February, I should say. Bright cloudy, you'll get 10%. So 12 kilowatts becomes 1.2. Then the special class of December and January, you get between 3 to 10%. And 3% is pathetic. I get almost no power.
Yeah.
Oh yeah.
We need to check this. We need to check this poll. I'll bet you anything.
Hey,
huge.
hey.
I bet there's a huge
Someone's
swing.
after you, Sean.
I bet there's a huge swing over the past 30 minutes or so.
Of what?
More people wanting to upgrade to Windows 11. I'm sure that the tables have turned.
It's still 60-40, Sean. I don't think it's going to work.
Yeah, I can't, well, yeah, I guess I'm not recording from here.
0.07.
So. Let's see,
So this is considerably lower loss. Double check just to be sure. 1.92. Oh, wait a minute. 1.033. That's correct. 1.033 at 25. So that adds up.
Someone must have hacked this.
It's 63. I think I know who the extra one was that pushed it to 63.
That was a comments are on this. I don't think anybody's commented in a while. I haven't received a notification. Yeah, 2 weeks ago.
Okay, so that concludes the test.
That also concludes the poll.
I win. I think you underestimate your fan base. Most people in the alternative energy or off-grid are already kind of fed up with that stuff anyway. I ditched Windows when it started telling me what to do. Don't turn off your computer, we're installing updates. I just said shut down. On Linux, I got control again.
Sorry, Victor, I don't understand your language, unfortunately. That Arabic?
It looks like an Arabic. That's not Russian.
Linux all the way.
I mean, I will say,
you guys disappoint me. Disappoint me. All you Linux users out there, I'm going to charge you an extra $500 for this inverter.
Our billing agreement and have you refunds. I will say Linux isn't for everybody, but for those that can use it, it's well worth it.
Maybe someday I'll take the plunge. I have used Linux before for plenty of stuff.
I mean, I will say, for those that use their computers heavily and are very techno geeks, if they're not using Linux already, you might... Hey.
Your brother supports Windows 11.
Another one of my brothers is an Apple fanboy, so I mean, you got it all. If you got problems, I know who to tell you to. Go that way. Not me. I don't have problems with Linux.
Mm-hmm.
Okay, so the tests on the transformer are done. I got the core curves, I got the resistance measurements. I'll actually calculate loss on that one versus this one and see if we can come up with the numbers. So we're dropping, that's a lot of voltage dropped. 3.25 plus 2.97 equals 6 volts lost at 50 amps. That hurts. 6.22 times 50 is, oh, that's not so bad.
I like hearing when you say stuff like that. Yeah. That's
1, 2, 4, 4, oh, me. 2, 4, 4 equals how much heat? So we're doing 50 amps, 124.4. 124.4. Wait a minute, I'm doing that all wrong. If it's 0.1244 ohms, that was my answer right there. 50 volts, 50 amps. It's 311 watts. So this one is not going to be significantly better because it's got the same number of wires. It's just shorter. So we have 2.18 plus 2.27 equals 425, 4.25, 85 milliohms. Wee-hee. 2.085 ohm equals 212, which is notably better. Equals to 12.5 watts of heat. So, I have my numbers now. Total loss plus 450 equals. The time you took a class in math, Sean?
I hate math. I really do. I
It's
used to like math when I was in high school. I was in advanced calculus in high school.
Why could you say your help on these data sheets? Because I don't understand.
Seriously,
calculus.
I don't know what it was. In my 20s, I started getting tired of math or something. I don't know.
So, okay, that's 662. This is going to be way worse. Equals 311 plus 864 equals 1175. Ooh, yeah.
What? Wait, what?
So, at 12 kilowatts, I'm not doing the math right. I know that. But some degree of error, that would give us 14 kilowatts. So, Sean, it's your calculus skills. We're losing 1,100 out of 14,000. What should that be? What's our efficiency?
If
If Divide 14,000 divided by 1170. Maybe the other way.
That's 85 plus.
Okay, that is 80. I'm down 1/10. Okay, so I need to do that. That would be 14,000 minus 1175 equals output is 12.8. Divided by 14,000 equals 91.6. We're not getting that. Equals 91.6%.
Oh, you're calculating at 14,000 watts, not
Yeah.
12,000?
Yes. Well, I'm calculating 14 to allow for losses because the losses have to be made up on the battery side. So if I have my math right, 9.6%. It's obviously not right because you measured 88 pretty clear. And I know it's not doing 91, but the math says 91.6 for that. Just measuring transformer losses, not switching losses, not transfer losses, none of that. Just straight DC losses. Whereas the new one, still running for 14,000.
Rick says 92%.
Well, he's right on 91.6. I won't take his math. You want to do the next one, Rick? 662 out of 14 kilowatts.
92%.
That's 95.2.
That can't be right.
It won't be.
It'd be one of the best on the, if not the best on the
So
market.
here's the thing. We measured that one at 88. So all I'm doing is measuring DC loss in the windings. Then we have switching loss in the FETs. We got switching loss in the chokes. We've got transfer loss in the transformer. But the bulk of the loss is the DC resistance.
The loss is because of resistance, right?
That's what I'm calculating. So the DC loss based on resistance says 91 for that and 95 for this. So we're actually several percent better. That's 0.952 minus 0.916 equals almost 4% better, which is significant. That'll take us from 88 to 92. No one else has a 92% efficient LF converter. At least it doesn't cost less than.
Yeah, it's not commercial graded.
Yeah.
Cool. So there you have it.
Yeah, I'm not doing an AC side transformer because, no, Elvery, yeah. I'm not doing an AC side fan because if the inverter turns off, somebody likes the fans to keep running to cool it down, and if you go power save, the fans can't keep running.
Yes.
And also speed control becomes extremely difficult. So that's why I'm not doing AC fans.
Yeah.
ruled
You
that
know
out.
how when you turn your car off, it actually gets hotter until you turn it on because the cooling fans are off, etc. So if this thing was blazing hot at 180 degrees and it were to shut off, it would just get hotter. It's just like, because you have no fans in there to pull that air out. So it's like roasting in there.
There's not more heat, everything's off. Technically it'd be inert, but my challenge is if it's AC powered, the PWM control becomes extremely difficult and it's not even worthwhile. Someone else said boost converter. I thought about that. The problem is I don't know of any boost converters that can handle 15 amps without requiring cooling or requiring a big bulk
That
of
would just be
space.
something else we'd have to put in the inverter that
It is.
might break and shipping and whatever.
The boost converter, it means it,
And it even might fail.
it would, and then you have no fans.
Yeah, exactly.
So
It's just another thing that can fail.
it's one of those things.
look at that. You put the little sink.
I did. So I brought those along just so we have a proof of principle. That's what it should look like.
You want to briefly describe what the plan is for that, just in general?
The plan for city. So the current method we've been trying to do with parallel and other stuff, I tried to avoid any cables, avoid any of that stuff, and just make it so wire AC input to the, doesn't have any labels on it, AC input to it, and it would use that to see voltage, frequency, or stuff like that, and sync to it. Works great, except when we're trying to do there's certain scenarios for parallel that it just simply doesn't work because we're trying to parallel two 120 volt inverters in split sync, split sync with AC input. We have to use the input separate. They can't be used as an input signal. And so the thought with this right here is that I can have it can be switchable on the LCD. I like settings. You can either use it in the original config. If you don't want to buy the cable, just hook it to there and you're fine. But if you need the input, you can hook the output of one to the input of the other and reconfigure it so that one's the output. They'll all be inputs unless otherwise configured. So the master out will provide a sync signal, and actually encoded in that signal, I'm thinking I can use it as a sync and a data transfer at the same time, so they could actually coordinate responses. Like this one says, we're full charge, let's switch to ATS now. And all the inverters in parallel instantly switch over. Normally this is done with expensive cables and expensive hubs and all this other nonsense. This right here, BNC cable.
You could very well have it also have, when you're logging into one inverter, it can see all the other inverters, so you'll have 2 or more inverters.
That becomes the challenge because this is unidirectional.
Okay.
So that would be nice. That's where the other ones with their fancy meter hubs and Ethernet ports and lots of complexity and greatly increased cost.
But you could modify the app though to say, okay, we got 3 inverters in this house. Here's all 3. Switch between the 3.
Yes. So if there's an app on your phone, this is with the Wi-Fi board. They have MDNS Discovery, and an app on the phone can do an MDNS scan and see all the inverters on the network, and you can see it all on the dashboard.
Yeah.
Obviously, we also could have right here. You see COM, a 3-pin connector for communication. All these are electrically isolated because some of the other inverters aren't, and that's an easy way to blow them up. So this is isolated, this goes to the relays, and this is electrically isolated as well. This would go to the Wi-Fi board. And so if you connect this right here, it can be based on ordering, RS-232, RS-45, or CAN bus. This right here connects to the Wi-Fi board, and you can connect it to an Arduino project, connect it to a Raspberry Pi, and directly communicate with the inverter and control it right here. That goes to the Wi-Fi board. This right here would be high-speed direct to the CPU for staying in sync. Is any voltage present on other types while running? Yes. So in this case, if we have these right here connected to the MOSFET boards, you're going to have voltage on the unused taps, but that's only on the 12K, because on the 6K, they're always in use. And if you want to be really bored, you can pull about 1 volt off the bolt to the chassis. It's kind of hard to run stuff on that, but you can.
Just as long as it's not like those days when I was getting hit with 120 volts.
It's
for
1
touching
volt.
the inverter. Oh.
You can hit this on a spammer. Let's put them in block. Let's report them actually. That's what it is. Okay, they're
Good
gone.
job, Sid. Good job being a moderator. I could have done that without you.
Okay, so all my measurements and tests are done. Yeah, the sync thing, we'll play with it. Basically, the A1 and B boards were fundamentally flawed with sync or parallel because all power was only available on the Wi-Fi board. The CPU would only see L1. Like if you look at all the other Chinese inverters, it's kind of funny. Power save is only available on L1. Something else only on L1.
Yeah.
They don't have a true power thing.
Mhm.
We have true power monitoring, but it used to be on the LCD. Now it's on the control board. So parallel in the previous incarnation will work considerably better because the control board had to wait for the LCD to tell it what the power was. And when you're doing it 3 times per second, that's really slow. And so the revised ones, you have a prototype board. Got that Chinese chip on, I couldn't get to work. Revised ones, the CPU sees the power, follows the wave of the current. Any of you with the C board, you can go to the oscilloscope and look at the output and input current and see the waveform. That's what's read by the CPU. So parallel regulation will be considerably better because the CPU is responsible for it full speed instead of 3 times a second. So
As long as it works out.
It'll
It's
work.
still in Sid's head right now.
it'll work a whole lot better. I haven't got back to that yet because there's many other features and things I need to work on and things that need attention. They're a bit more important. But I definitely want to
Your
get back.
goal is to have parallel. So if anybody wants to order one of these, they'll know that parallel will likely be
So
available.
and the next, so on the current ones with the C boards, it will likely be available. I haven't started on it. The functionality is there. We tested it. I saw power fly on your bench, so I know the ability is there. The issue is I've got the software ready for it yet. It's also circling the house.
So-
Just run by.
Yeah. So that's what we got to be clear on. If you're interested in ordering one of these, parallel mode is not going to be available on day 1, or it may not be, depending on when we get these.
Input voltage, okay, George Rick here. I can't see input voltage or amps on the GS Miner website. What are you doing wrong? Quick answer. Nothing. I haven't updated it yet. That's my fault.
Sid. Blame Sid and his Linux. See?
I haven't got to that. That's my fault. I was on the page yesterday. Yes, input volts and current doesn't show. That's my fault. So I got to get back to work on that. That whole thing needs redesigned. We had to start on the redesigned website thing, but at the moment, nothing's happening with that, unfortunately. So
So what's next, Sid?
next thing is we can throw the old main board back in and start trying. I need to start a list of all the things that power got messed up. Get the charger from
We're
my
going to have
laptop.
to get rid of this cable, right?
That's
Oh,
C-board.
that's my C-board.
Oh, that's your C-board.
Sid's here to fix it if it broke.
I don't see anything wrong with it.
Oh, you're good.
So yeah, that's
Well, no, well.
power up test will be fine.
Are you sure? Just want to make sure something blows up. We're like, why did it
Well,
blow up?
that's what I was looking at, is right here, on these right here, because it hit on that corner.
Oh,
Those-
okay.
Those
Well,
are soldered well.
That's fine.
And you do have the new driver. You should.
It's the right color.
It is the right color. The wrong color driver is a bad day.
All right, so I get rid of these cables here.
So I need to
You need this for now?
get some power to my laptop.
Oh,
So obviously the new board, yeah, throw it in right back here. Need to buy a new battery for it, so I need to do, but I'm too cheap.
jeez.
Give it to me, and it's probably 3 years old. The battery is in pretty low state, let me say. Okay, so the case here, they got these screws on backwards. I need to find my list. New document, plain@anna.com. Gotta do what you gotta do, right?
Yeah.
I'll go back to those files and revise it and correct the stuff they messed up. What I really want to see is going to be difficult, but how the cover fits on it. Because I did round the corners off here, and that came out pretty good. But those screws can't be moved up, and the other one should line up perfectly with it, but it doesn't. Where's my complaints.doc? Okay, I'll put it in there. New document.
We're gonna need lock washers on some of the stuff, and we're a little bit
On what?
like the cables that were running to here. I tightened them up. They were kind of loose. You could kind of move
Well,
them.
those are gigantic cables. So
Yeah.
that's, we don't need to
Some of
do
this stuff I just want to make sure that we have
Yeah, so
lock washers for, but it's not gonna, be a big deal.
I will say,
Some of this stuff I just want to make sure, even in shipping or prolonged use, because I can't wait an hour and retorque them, as I'm building them.
So I will give it the company for the bus bars here, and what was yeah, I was actually wanting to put studs on here,
Oh, nice.
so threaded studs. So
Yeah.
you just walk them straight. That was the first company that I fired actually had studs on. It's like, that looks nice, but then they said, oh, we cannot make before Chinese New Year. It's like, come on already, you got a week. You got the design. We don't be able to do it. You say 2 weeks, I go downstairs and cut it and bend it by hand in 2 hours. So I found a different company, lost 3 or 4 days getting the design communicated to them, and we got them. Shipped before Chinese New Year. Like, well,
There you go.
so what?
All right.
Okay, first thing I'm gonna do on that is remind myself, where's my meter? Right back here. This one uses the FETs that China says they can't get anymore, which is slightly problematic.
Run out of room here.
Because the FETs I'm trying now, same manufacturer, same part number, just different suffix. They seem to have considerably more gate capacitance and are being a lot more difficult. Let's see if we got it. I'll verify here what we got there. Can you switch battery banks while under load? What do you mean? You mean you disconnect one and smash it on another under load? You're gonna have a big bang and probably blow the inverter up. This right here is low side. We should have.
So I would assume that that's a no on the switching of battery banks, unless they're absolutely equal,
If they're
right?
the same voltage, that's fine.
But if one's under a load, like 8 or 9 kilowatts.
Also, if you're taking, if it's a make before break, you're fine. This was
Mhm.
on, both short together and then short over. You're fine. Nothing changed.
Connect
if
two
you're doing-
packs in parallel, wait 2 seconds, disconnect one pack.
Oh no! Oh no! It's gonna be, if it's under full load. People keep saying these caps are better with surge. They don't have enough energy to do 1/10th out of the inverter for a fraction of a second. All they're there for is to to keep the FET switching from turning the cables into boost converter and blowing everything out. Without these caps in there, the voltage goes everywhere and it goes smoke really fast. As another of our very good customers discovered by accident, unfortunately.
You stand up.
We learn.
I'm missing one apparently.
And yes, we got more ohms on the top. So the test, the ones that worked on that main board doesn't work on the new ones, but that's what it is. Sort of type.
Those are tall standoffs. Oh, no.
Okay, how tall are your standoffs? Would they need to be 10 millimeter?
The ones that are on there.
Did
Oh,
you
I
have-
found one.
So the thing is, I specified this bus bar for 10mm standoffs.
No, I was talking about
Oh,
these.
oh.
I'm missing
Oh.
a standoff. That's.
I drilled those out for you before. Okay. One thing with Linux, files are in a different location than you're used to. But you get used to it.
Yeah, just confusing as all heck. Matt Stubbs says, "There is my man. Hey, you coming to wash my clothes?"
Yeah, I saw his message on the forum. He has a very, very persnickety washing machine that keeps throwing fits with the inverter.
Apparently.
Because we got a revised version that had more caps on it, I think. I
Can
forget. It's
you
been
add
months.
more
You
filter
can.
caps?
So the thing is, if it's complaining about that, I don't know what his inverter has on it.
The no load would go up, wouldn't it?
No load will go up, but if that makes the washer happy, then you gotta do what you gotta do.
Yeah, we can. You can just add a cap to the front connectors.
Okay, you can.
So
Yep.
you can do it yourself if you wanted to.
Yep.
Solar charge controller in a future model.
Not integrated. Not integrated. Actually, I'm trying to get this as small as possible because trying to do the 400 or 500 amps. But I got this big thing to do a charge controller. We need at least as many FETs to do the same number of amps. It gets messy real fast. It would probably be about the same size as this.
Which way does this go? This? No, that's not that way.
Goes up
This way?
Yep.
Okay, I need some smaller screws then.
Well, these right here. So the whole size here I put in the drawing was for threaded, tapped and threaded, and it's supposed to go underneath like that right there.
Ah, okay.
And so the tapped and threaded, you have a small hole, and then you run a dual and tap through it. It actually works out really well. I love having to put a kink right here so it doesn't touch.
You want me to turn off this power supply?
Yeah, you can. But yeah, these right here are oval. On the revised version, they should be rounds and fours. I've done a lot of changes to the board to some. Yeah, that's the way it should.
Well, is this the revised version?
No,
Okay.
nope, haven't ordered them
This
yet.
one is identical to the one that's there.
Perfectly identical, except different FETs and different problems.
Okay,
So,
all right. Well,
that one's
this is our
there.
problems.
if I have time tomorrow, I'll delve into that one and try to get the FET thing working better, but yeah, I gotta have a solution, because this right here works fine. But if we can't get those FETs anymore, we're in trouble. And of course, I did this, we can show that.
Oh, now we're gonna do a comparison.
Heat shrink. I put heat shrink tubing on it. Still takes
Don't,
me,
don't drop the control board.
still takes me an hour, 2 hours to make one cable, but that's why I'm not doing it in production.
Yours is nice and shiny and new looking. Mine's all old and used.
Yours is proven. This one right here is not proven. And if it wasn't, yeah. So there's the,
What? Oh, this is for testing?
yes, I'm in for testing. So that's the screw I want to use on these because it's got the ridges on these right here. There, see the shrink wrap.
Yeah, there you go. Much better.
That will be what they professionally do. This right here is just get the job done.
So we are sticking with the old one that was in the prototype for now.
Yeah, I'll play with the circuit on these.
Sid
in the
is still
morning.
experimenting with FETs on that one, so.
Yeah.
Haven't dialed it in yet.
Problem is that Miller capacitance. Apparently on the previous FETs, the 30% difference in gate capacitance or reverse transfer capacitance makes a huge difference. So actually pop this off. For these two. Don't need to.
What are we using to run from there?
I need to see where it lines up, and I'll probably drill holes. Oh, gotcha. The other one over there, look, it's got screws across the whole top of it. We don't have them on this one. That's gonna be a problem.
It's true.
I brought a piece of aluminum, actually a power jack heatsink, to just bridge the gap between the two, but this doesn't have a hole there. And you probably don't have a tap and die set.
No, sir.
And mine is not metric.
Ah.
Okay, we have standoffs in all the right places. Oh, yeah.
Oh, we have
Oh,
what?
we have clearance. We're good.
Oh, okay, good.
We're good.
And those are good.
Those are good. Full of glue. What have you done, Sean? You fill the standoffs full of glue.
Well, because we didn't have any, the holes didn't line up, so I couldn't use screws.
Okay, what's the matter here? Did I get the hole in the wrong place?
The
I put the holes on it.
Yeah, but the prototype used a power jack main board, remember? So the holes didn't line up.
Correct. This one right here, the pattern is different. It's designed for this board here. And so I revised the location of those holes, but they're not on
Yeah, I mean, we can easily heat this up and get rid of this glue. That's not
Yeah,
gonna be an issue.
let's check with this board here, because I can see right through it.
Or we could just have it sit there. It doesn't have. It's not like I'm traveling with it.
Well, so the purpose of this right here is to get the design issues sorted out.
Yeah, that's fine.
So,
But I mean, this thing's literally been just sitting here for
Yeah.
the past year.
but if this is wrong, I gotta fix it so we make an order.
No, that's true. Man, I got a lot of dust in this place. Man, and I blew this out at least once every 2 months.
Yeah.
Just dust down here in the basement is just terrible. It's just the way it is.
So we'll see. Hopefully I have time to redo the moss boards. I brought all the parts for that. Let's take these off of this.
Elvery says, my washer is now happy. Just have said look at.
Yeah, because I gave him more cat. He's both had the same issue. Here's the
What's with the washer or the washing machines are just
they're too smart for their own good, and they just decide not to run cycles because the power's too dirty or it moves too much or something like that.
what do they need, a medical grade inverter?
I don't know because it works fine on mains, and it doesn't work on inverter, and I have an HE washer that I got for free because it didn't work. And no issues
My
whatsoever.
washer doesn't seem to complain either.
No issues at all.
New within the past 2 years.
And so the problem is, Matt's down in Georgia, I think. And Elvery is down there in the Caribbean, so both are a little far away for me to drop in
Yeah.
and see what's going on.
Let's see.
No offense, Dan, I know it's pretty in those places, but I mean, seriously, it's a bit of a drive. So that's there. Okay, I definitely got those holes in the wrong place. Why is it?
Ryan says if we ever do decide to build a charge controller in the future, don't use measly 60 amp controllers. Nothing less than 100 amps.
I agree.
300 volts max input as well, not 150.
Yeah, here's the problem. These requests are very valid because that's what I would use. If I had something like that, yeah, I'd use it. But we have major efficiency issues because 150 volt FETs, these are 100 volt FETs. 3.6 milliohms on resistance, which is fine. If you go to 300 volt, you'll be looking at 8 to 10 milliohms, so 3 times the loss in heat in the FETs alone just to get the voltage. At 300 volts, you almost are getting into the realm of an IGBIT is better, or you can use silicon carbide FETs, but those are a lot more expensive, and it just gets really messy.
Quite a lot of flux there, too.
Yeah, but the control board on top holds that, and that's why there's a screw right here.
Okay, good.
So
I don't like
I
that flux.
messed up these somehow. That one lines up in the back. That one's good. These two don't, and that one's way off. So what's the matter there? It's way off. I do have to be careful though. It might not be my fault. It might be those Windows machines in China that can design out sent to.
They're still on Windows 7.
Yes, they are. That's the last one I can stand. Okay, I need to check that. Mainboard screw holes do not line up correctly. I gotta check to see if that's their board revision thing or design revision. This one right here, perfect, perfect, perfect. That one's about 10 millimeters off, and these right here, 3 millimeters off. Dang. So I've got to figure out why. And we got a lot of space here. I really kind of wanted to slide this whole thing back.
You do like it as close to that front as possible, just as long as there's no chance for that front to come into contact with that heat sink.
Because that would be bad.
Yeah.
It's battery positive, but still the thing is, if I can get it closer, we can make the whole chassis smaller.
It may be battery positive, but somebody's probably going to ground this, so that's going to go straight to ground if they decide to ground the chassis.
I think China's at fault for messing this up. Because they kept moving things. Their engineer would look at it and adjust things.
Mhm.
And I look at the design and say, that's not right. And one of these right here, they shut those things in because it might be the way. I say, no, it won't. I calculated it out. But I'm seeing here, Sean, you can see, I obviously got it way wrong. I thought it had a bolt from here, just a metal comes straight out to the heat sink. Because the hole is way out there. I mean, I didn't do that. I was expecting this to be up closer to that, and the length of that, we are way off in measurements. This right here should be 40 millimeters. I think it looks like they pushed it to 50 or 60. It's 50. Our guy moved it. It should
So
be
they
40.
messed it up.
That means our bus bar won't fit. Because they messed it up and I didn't catch it. Ah, I gotta love it.
Crap.
Yeah, it should be 40 millimeters from the edge. throw it in and see what happens regardless. It might fit, but it shouldn't if nothing else is moved.
I mean, yeah, as long as you're taking notes, we can move it wherever we need to for testing.
Yeah, if I go to salt it out, it's not going to work
Yeah.
for production. Because that is further back. Something's gotten moved here. Because you get 30 strands of aluminum wire. Kind of hard to move. This right here is further back than I want. Yeah, look at it, Sean. They moved the holes up on me in the case.
Oh yeah, I see it.
Because here's where it should be, right here. Out there. It should be 40 millimeters from over here. 40, 45. It should be 40.
For testing though, we can stand it up, right?
Yeah, we're fine. It's just a matter of production. Things are really messed
For
up.
production. You're gonna have to make sure you yell at them for sure. This here that you're seeing right now, that we're experiencing right now, has been this way since day one of the very, very first product. This stuff just happens. No matter how good you are about, no matter how good Sid is about the holes go here, bend this here, tuck this in here, do this. Sometimes we get something that's completely different.
So,
Case in point, unfortunately.
that's the drawing file they sent me back. They had double transformer holes.
Is that necessary, the double transformer?
No, it's not.
Why did
But
they
I
do
left
that?
it that way for prototype. They actually did triples on this. The drawing they sent is doubles, and it's got triples.
Who's working their machine anyways?
Yeah, we got issues here. Well, this would be the same with anything else. So technically, they wanted a three-dimensional layout, which is fair. I'm just not any good at doing 3D layout. I'm struggling to do two-dimensional on LibreCAD, which is fine, but when you bend things, you have bending loss. It gets shorter when you bend it, and things like that. Did you ever find a metric measuring tape?
I don't have one.
Get one from Jack.
I'm American.
Well, the problem is all my designs are measured in metric
Yeah,
because
I
that's
know.
what China lives on. So
I mean, I've got the calipers if you want to use those. Those are
I need to get
metric.
the whole width of this right here.
Oh, well, never
I'd like
mind.
to see you stretch your calipers that far, Sean.
Well, we
Get the
could-
Windows
we-
10 ones.
We
They're
could,
bigger.
could mark it, all the way to here and then go from here to here.
Yeah, that's what Windows users do.
Yeah, we find a solution to a problem.
My solution is use a longer stick to do the same thing. It's way easier. Where? Because the latest file they sent me, I can't open.
Let's see here. I know your brother's got a couple things to say. Let's see, where am I at here? Yeah, okay, right about here. That's where we left off. You got it set to 179, don't you?
Should be default 180. Well, no, I currently have those at 130, so yeah, I can bump those up. It's something to toy with. You won't be happy you'll send them to 99
wow.
full speed.
As long as it doesn't overheat, I don't care.
Oil soak transformer, that's not really viable because oil soak transformer, people talk about oil filled transformer like it's the best thing. The thing is, what it's good for is conducting heat away from the windings because oil is much better at conducting heat than air. But at the end of the day, you still have to put that heat somewhere. And actually, if we wanted to be technical about it, the best way to do it would not be oil filled. It'd be epoxy coated, because I was actually working with someone else. And various epoxy we found a thing on, it's actually 10 times better at conducting heat than air.
Okay.
And the thing is, if you conduct heat 10 times better, you still have to put it somewhere. My MPPT, the Morningstar, and the E-Beggars, they all have the inductors in epoxy, so you can easily get the heat away. Sure you guys don't want to cover exposed metal? It would. So,
But if anything falls on the control board, it would short something out.
well, yeah, because none of the boards. So this right here is inside the chassis. It doesn't really matter.
Yeah.
These will be nickel plated. If we want to pay even more, I could have them. What's it called? PVC coated.
But is there a point though?
There's
If
no
something
point.
falls in there.
Here's the thing: if you have something falls across these heat sinks, you're in trouble,
Yeah.
big time. So something falls on the control board right here, bam, you're in trouble. Something falls on MOSFETs, you're toast. So this right here is out floating around nothing. If you short it here, it's ground versus very positive, likely nothing. short to here, blows that, short to here, blow its battery dead short. But that's the same with right here. Straight across here between negative terminals. So
Is it drastically more expensive to coat it? I don't even think we need to really.
I don't think so. They need nickel plated so they don't oxidize.
Yeah.
But here's the thing, the new company I went with is so much better because they were so close to holiday. They managed to get 2 out. I know they got a bunch of other orders to do. They managed to get 2 out. They didn't nickel plate it because the nickel plating team was already on holiday. It's like, that's fine, just send them. I know you can do it. So PVC, they asked about PVC, it adds the cost. I don't see why we need it. It's not like we're layering these things or stacking around stuff, so I don't think we really need that.
As long as those windings can't touch it.
Yeah, that right there is a major issue, right up there against it. I don't like that. But the dimensions here are not looking like I thought. This right here will be the rest of my day probably sorting out the issues with this before we test it. Because I need to know what to do to fix this. All right, I probably fixed it. You got a number 2 driver for your drill. Because they keep putting the screws on. It's funny, they can never seem to get the battery binding coats on right. They got the right screws with them. They just never put them on right.
Yeah, and
First inverter, they put them on backwards and the post sticking out. Like, come
I
on.
hope they fix that because I don't want to be doing that to every inverter that comes in.
Well, I've never had these terminals in hand, so now I've seen that they come with screws. I can yell at them proper. Okay, so these, is that different?
Wouldn't surprise me.
Those are their screws. Okay, they threaded these. Did I tell them to thread them? Let's look and see if they did it without me telling them to. There's the DX.
They are threaded.
They are threaded. I don't think I said to thread them because they won't work if they're threaded. January 2022. So, okay, there's the design. Did I say threaded? Is it my fault? Technically, yes. I said M4.
There you go.
It's my fault. Okay, look at it. It's got a space for a nut in it. That's so you're supposed to put a nut in it and leave the thing sticking out so you can
Yeah,
put
that's
another
true.
in. That's how it goes. So
Heard you would have to send that to Sid, not me.
I've got one. I just didn't bring it.
Oh, okay. So Sid does have one, he just didn't bring it.
You want to get a drill bit? Or I'm gonna strip this out. It'll be right. Oh, that's in there way better. Stop. Go drill bit.
For
Trash those threads.
you want to destroy the threads?
Yeah. So that needs to
mine
be
through
drilled
over.
straight through. That's my fault. I said M4 is not designed. Okay, we should be 40 millimeters. So 45 millimeters from the chassis edge. This right here does not line up at all.
Is this thing big enough?
You don't want to be bigger than the head of the screw. That's a little big.
Bigger. I mean,
That's too small. That's gonna go right through it.
all right. So I need to find.
What's this one right here? Oh, too small as well.
Yeah, it's too small. Got all the
I
small
like their
ones.
miniature screwdrivers. Are these a gag gift or something?
Yeah, they were.
Looks like you used them.
Actually, I have used them. There were certain situations where they did actually come in handy.
I can tell you bent the things. How do you get a straight screw input with a screwdriver like this?
I have the bigger. Oh yeah, I know. I only have the bigger. I don't have any medium size.
Well, we can use an oversized one. This is going to be a lot harder. Hopefully these are standard M3s. Okay. I don't see any reason why these terminals shouldn't be 400, 600 amps. I mean, we're
a
at
little bit set. I usually just buy one bit at a time, based on what I need.
these things right here. Keep dropping the bolts. Are these your bolts or theirs? Did they include these bolts with it?
No, they did not. I bought those.
Okay, that's so we're a solid 20 millimeters across.
Mhm.
Completely solid. So that's we can use an oversized bit. I don't think your machines won't like it because we're going to stainless steel. The 12K be able to be wall mounted. It's designed wall mounted. So SAE tape measure easy to convert. Yes, it's easy to convert. However, I need the accuracy, and if I get my SAE off a little bit, my conversion won't be exact because my entire thing here is spec to millimeters. The entire sheet.
It's in hammer mode, by the way.
Is that a hammer bit? You got a tri-wing bit on it.
There you go. Take that main board out of there.
Probably
so
should.
stuff doesn't fall in on it.
This isn't going as easy as it seems.
Pretty thick. There it goes. There you
Yeah,
go. Sid.
nice
Nice,
one.
nice job.
1 of 8. Don't overheat your bit.
Slow and easy wins the race.
Can we put this in low gear?
There
It's
you go.
wrong for torque, but... Huh?
Turn it to 14. There you go.
Milwaukee's broken, you mean?
No, no, just
Oh,
That's
keep slowing
the-
down.
no. I mean, just yeah. Any of the numbers is fine. There you go.
Okay,
That's not too bad.
not going too bad. You can't drill threshold with it, but I need to start taking pictures and logging everything down.
You want me to do that while you're doing the pictures?
Yeah, you can. So right off the top, we have problems. Mainboard screws not lined correctly.
Let it cool off a little bit.
You got that hot?
I just don't want to.
You dump oil on it for.
I have cutting oil out in the garage somewhere.
I use car oil.
Yeah.
We got more garbage. Let's report this as well. I don't know what this one is. I have researched it, but. And it's okay to load a hanger plate to mount first before hanging an inverter. And someone else has also asked if we can make a rack mounting case. And the challenge with rack mounting is the display and button at the top right now is on a rack, you can't access it. But basically, so they're thinking there, a microwave oven came with that.
Mm-hmm.
You mount the bracket on the wall, and then you can hook the back of it on there and hold the front up. It's really handy. So, yes, designed to be wall mounted, and that makes it a major challenge because it's so heavy. I saw a video of someone mounting, what was it? It wasn't Ames, it's a GFL the same. And they used block and tackle and chains to winch it up.
Oh yeah, that's what you're talking about.
We can put drywall on it to be the fire barrier. It'll be white. I like to see you put it up though.
Yeah, this is where I work, so I'm not
Yeah,
really.
not
I
too
mean,
concerned
I
about
normally don't have the camera over here. It's
Normally over there.
normally over there where it's properly lit.
Yeah. Okay, so
Well, how's the top one?
you have a rat tail file, rasp out the back. You probably don't have one.
No, I've got a file for the.
Or you have a chisel.
No, I've got the
You got a Sharpie marker. You would use that. An oversized king size Sharpie.
What?
Feels like an empty can.
Yellow.
Oh, where's the power buttons on the inverters that weren't working?
Power buttons?
Yeah, you said it's been 2 buttons. You said were faulty. Would stay on. Where's
They're in a box somewhere. I'll find it for you.
Yeah, I need to look in those.
Oh, did you need more fats, by the way?
Yes, I do.
Okay.
Yes, I do.
Take
2 bundles.
basically as many as you want. I've got a bunch of here.
I'll take a 3rd bundle because
Just in case.
I have none in my test bench right now, and I sent some out to solve issues.
I don't know where my file went.
So here's the brackets for the first 12K prototype. Those gigantic old things. Come on.
Here. Want to use this?
Dremel?
This is what I used to sharpen the chainsaw with.
Oh, okay.
That'll be fine. Here, you want eye protection?
Yeah.
Here. We're live streaming, so. Alright, I'll wear the eye protection.
You want to do it?
No, I'm just trying to stay safe here, you know.
Uh-huh.
For the camera.
Uh-huh.
Let's do it again.
We see a disclaimer like Jimmy's World.
Sid, can you explain the Pro Cool settings and what they do?
So Pro Cool is a Sean feature.
Heck yeah.
I don't think your bit likes stainless steel very well.
Well, that's probably.
I don't think it likes it too well. Let's do the job. So Pro Cool. Pro Cool setting is not professional cooling, it's proactive cooling. I have limited space, which is why someone will probably point out the model is misspelled on that screen as well. It's because I have limited space on the screen. So Pro Cool is proactive cooling. It basically sets the minimum fan speed based on the percentage of load. So if you set Pro Cool to 100%, at 100% load, minimum fan speed will be 100%. Pro Cool at 50% means a 3 kilowatt load, fans will be 100% minimum. And so it throttles down. So if you're down 0, the fans will still go down to 0. Pro Cool of 10% means it's 600 watts, full blast. I mean, it's not very practical. We're not done with that one yet, Sean.
What?
We've got another 4 holes to go.
Yeah, that's fine.
You're swapping it out already?
Yeah, well, this is the bit that I use for my particular chainsaw.
Okay.
So this is getting wore out, and
So it's different size, you're saying?
yes, there is.
Okay.
So I'll take the one that's mine.
So yes, Pro Cool is proactive cooling. Just throttle the fans up before the inverter gets hot. I don't see too much use in it from a development standpoint because you can't take away heat that isn't there yet. And if something is starting to generate heat within seconds, you have a problem the fans won't take care of. So it's going to gently start up, speed up. That's your call it down there.
Yep, thank you. And
But in the case of the thermistor's not measuring a hot spot, it can be of great value then. But that's a design issue we need to sort out then. So what's we got here? Oh, it's going up and up and up.
Ooh, that's kind of.
Hey, Kurt, we're here to show the reality, not a polished product, unfortunately. We're not doing $1 million live streams.
Yeah.
Stainless is hard cut, regular cut. You are right. You had a second control board on a 15K, huh?
Is he talking about the main board maybe?
I'm assuming that's for a power jack. You had a second control board. Huh? Another main board?
It's a failsafe, Sid.
I don't recommend it, but hey, it's a power jack.
Alright, that's a better.
This is what you use for erasing mistakes on the pencil?
Heck yeah. I'm gonna have to buy another one of these. Looks like it's wore down a little
Well,
bit.
you can run down here, right?
Yeah.
It's not done yet.
Mm.
I don't think your bit likes stainless steel.
I don't think it was meant to cut stainless steel.
Yeah, most aren't.
I've got, what?
It's not grabbing anymore.
I don't know if the step bit's gonna help at all.
Well, yeah, I can't get it tight enough is the problem.
It's a prototype. Get it right perfectly, then.
I can take the other one and just run straight through. The problem is I can't, if I put it in the right way,
What about the top one? Is that one working now?
the top one will work fine. So I just need to go to your box and find nuts that fit both these things. It should just be a standard regular M3 nut. They can't have a lock washer on that. These look too small. But they are. And your M2s, I'm assuming? There's lock washers, spacers, long power jack push buttons. If I pull it from here, you'll be short, so these look like that size.
No, that's fine.
Oh, they're too big.
Are they?
Oh no, what are we gonna do? These are the official screws. We don't have the nuts to go with them.
What? Where's the official screws at?
I got one here in hand. So the thing is, here's
the drill bit.
here's too small. But the size of the stat's too big. But they do look like very oversized screws.
It must be a different thread pitch or something.
Well, those have a big lock thing. This has to fit in there.
Oh shoot, that's right.
Yeah, so we can't have a lock thing on it. I got a full drawer full of those here, but those are too big as well. So something is.
So did they send us? Wait, no, that's not it.
They didn't send it nuts, they put it backwards.
Shoot, you're kidding me. And I don't have anything left over from the first inverter, I don't think.
Well, the first one is over here, but all the screws are gone. We got 2 sets of terminals with no screws.
Oh, that's disappointing to say the least.
We got the dual fancy terminals and no. Those are very tiny screws, very tiny nuts, I must say. Very tiny.
Yeah, I don't have anything like that.
We got smaller ones, we don't fit those screws. I mean, is that the same size as this? Let's see.
I guess for my unit, it doesn't matter if it looks beautiful on the inside.
That's the size it is right here. That's pretty useless. So those standoffs are the right size. We're not cut that in half. We have a nut.
Oh my.
You get a hacksaw, you cut that right off, and we have a nut. Looks stupid doing it, but it would work.
Well, like I said, for that thing, I don't care what it is.
Well, you have a hacksaw.
No.
Ah.
See, there you go. Need to get a Milwaukee hacksaw.
No, I'm talking a hand hacksaw. One you run by hand.
Oh,
I'm not talking about sawzall. Those are too nasty. Anything I can put in the device.
oh, here's my file. Oh, I found my file. Okay, that's cool.
Do this right here. It's got a bunch of them. We cut it a lot of times. I'll stand on this 1.25 inch long. Probably even the right thread. There it is.
Hold on.
If we can cut this right here 4 pieces. You got 4 nuts, Sean.
Hold on. Hold on. Hold on. Hold on.
So penguins do best.
You got your flights, right?
Yes. My little bench vise.
You are going to have to wear safety goggles for this.
Uh-huh. Oh, you got a cutoff wheel. Oh, those are nasty. I should have brought earplugs too. The vise is right there, actually. Yeah, I will wear safety equipment for that. Those tools are nasty.
Heck yeah, they are.
Right next to
This
that's
will
actually
make quick work of that.
it's right next up there with an angle grinder, which those things are nasty. Very useful, but
Make
very
quick-
dangerous. Okay, Jerry Rig 101.
Look at us doing this on camera.
That wasn't my idea.
Everybody's probably laughing at us.
Hey,
We're a bunch of idiots.
we don't have the right size, so we're gonna make do.
Yeah, it's not going to take very long to cut off.
No, but do you have hearing protection with that, or just glasses? Move this because we'll splatter with metal. Don't break the current set of wires on the back. Okay. And yes, we are doing this because that's what it takes to get the job done. Okay.
Cut away,
Which
Sid.
way to spin? Oh, I might cut your Windows laptop.
Cut away, Sid.
Okay, so it goes to the right. So I'll be spraying your heater. If I do this way, it'll go on the floor.
Okay.
It's a right-handed tool again, Sean.
Here we go.
No, that's not gonna work. I don't want to throw sparks all over your.
Cat, that's right at your feet.
Yeah, that'll be fun to watch. Just don't tell those PCA. It goes down. Still like backwards. That's gonna set the sparks right on my.
It's not going to be that much. It's not going to take very long for it to get through, so.
Well, you're speaking of someone that burned a hole right through their coat and all the way down to their shirt.
It doesn't
Before you
matter if that
realize-
shirt gets burned. I don't care.
Okay, we'll see. I'll take your word for it. It's going down, so we should be all right. Don't cut my vise. These need to be how deep? 2 millimeters, 3 millimeters? Oh, safety, child safety.
Done?
Moving too much.
Oh. Hot?
Probably will be. The device isn't holding a straight light on it. Well, it takes a huge bite out.
I have got a bigger vice if you want to use that.
Probably a straighter jaw with this little toy. This is great for electronics, but when it comes to doing big stuff, you better get a bigger one.
There we want it?
Yep.
Pretty tight.
Still moves.
How did you want?
I'll make an oval. Then I'll have to retap threads through it. Try this again. Oh, now we can weight the vise. Get it? Mm-hmm. That's gonna be scorching hot because I can see the metal's different colors. So we got pliers. Dikes will work.
I mean, this.
Wire skippers, whatever.
All my pliers around here somewhere. I think they're on the stairs.
All the right tools, right? We need. Problem is I didn't cut that all the way through. It'll be all right. So now.
Yeah, smell it.
Yeah, lovely things.
All right, let's see what everybody's commenting on our jury rigging. This should not make mixed lead acid, and obviously. Where did you read to? There's a lot of comments coming in.
That's the last one I was at right there. Okay. 20.8. Are you going to change? Ryan says you can change the design of 6K to the 12, but make it smaller. That is the goal.
Mhm.
That is the goal. That be 6K. Okay. I'm glad it works good.
Nothing's really wrong with it.
Well, the AC input is got its challenges, but it does function. So, lead acid. Yeah, you can mix lead acid and lithium iron phosphate. The thing is, it's going to cycle the lithium iron phosphate really hard. And that's, yeah. You shouldn't, for the best things, you shouldn't mix it because it's going, the lead acid is going to drag the lithium iron down. And the lithium iron is going to cycle first because it has the same voltage. So, how big is that basement? Door going off and more basement. Yeah, whatever. Yes, it's a matter of cycle things for mixing chemistries. I don't recommend it because it's going to cycle one way harder than the other.
Did not get a shirt for Sid yet.
Not build a wall from the sounds of it. I mean, it's a matter of cycling. So you can mix them if you know what you're doing, but it's going to cycle one way harder than the other and lose capacity because lead acid will pull it back down.
I didn't really think anybody was interested in these shirts. I had this one custom made just for the videos, literally, just for the videos. And I didn't get Sid one because he's not really up here in the videos all that often.
Yeah.
And I already got him a couple of Windows 11 shirts, so we're all set.
Right here.
See?
The window's what breaks. Okay, let's see if the jerry-rigged nut.
Still hot?
It fits.
Eh.
Now let's see if we can put a nut in it.
Now wait a minute, we did that 4 times.
Yes, 8 times.
8 times.
Welcome to jerry-rigged shop.
Yeah.
It actually threads through. So now if I keep my finger out without shredding my finger on the nut, and that's all the way through.
You want me to, here. Hold it with this.
Bingo!
Okay.
That's the way the terminal should go.
Just for now, just do 2 each. I mean,
Yeah.
we're gonna waste a whole bunch of time just working on this cosmetic thing.
Well, cosmetic, but also structural, because it's what holds the terminals up. The next
I
thing
think
is
2 is strong enough for now.
Yeah, because 2 is all we need.
We can order the proper ones from Anna.
Yeah, they'll get it right on that. Because the cover, we could care less about, but the cover, those screws have to go all the way through the cover, right here.
Yeah.
Put it on the wrong 2, so you only put it up and down. That's not very helpful. Not left and right.
That's perfect, Sid.
So then you have to thread a nut by hand on top of that to hold the cover open. It's not the easiest, but it does work. I did put it on the wrong one. Yes, I put it on the wrong one.
I like the up look. Yeah, that's great.
Yeah, have the internals off the top and off the bottom. Oh, and the screws in that one too, so I can't just move it. It's down here. Oh, the joys of designing something. It's not as glamorous as Hollywood makes it look like, that's for sure.
Apparently, a judge or solar has fanboys.
Well, that's a good thing. Pocket teeth. Oh, uh-oh. If you know what you're doing, yeah. If you don't do it. Hey. You know who that is.
Yeah, I know who that is. And yes, I am pacing. Why? Because we got a lot riding on this. It better work this time, Sid. This is a year in the making. Sid, took us a whole year to get here. Now I'm getting dizzy.
Well, you want to be cutting these off while I'm wearing the safety glasses?
Ooh, oh, yeah, that's clever. How much do you need off?
So I tried to get, see how shallow that is?
Mm-hmm.
So to start here, I got to clean that up a little bit.
Thanks for the warning, Sid.
You can mix any lithium cell with ultra caps. That's true. The trolls are out, Sean. I'm sorry. Where is that cat? You're supposed to be doing all that pacing.
Sid is a busy bee. Yes, he is. I don't normally work in this shirt because I don't want to dirty it up.
Well, it's the first time I've worn this shirt for proper, and I can get all the evidence on it in one.
Afraid I'm going to get it all dirty now.
Like I'm talking about celebrities. Oh, they reused an outfit. Well, I've got a machine called a washing machine that does a great job of recycling outfits.
All right, how tall is that?
I'm trying to get it flush with it, but I didn't get this anything close to straight. But it does thread on.
Does it?
Yes. Should be sitting right in there. What are you looking for? Oh. Safety second. Safety squint first.
Clean this up a little bit here.
Just break it off. Not on the floor.
Good enough.
I just break it off. And
I guess it's dinner time, Sid.
probably.
We're down here modifying things.
Yeah. We're doing the Hillbilly special.
All right, so we are going to take a quick break for lunch.
Lunch.
Or dinner,
You
sorry.
work a third shift?
Yes, I am.
I got to do a bunch more measurements, a lot more qualifying stuff to figure out where stuff went wrong.
Was that one good enough?
Yeah, I said over here to cool off.
Okay.
I mean, it'll work as long as the cover fits on. We're fine. So
Okay.
yeah, it'll work. So any further?
No, I don't think so.
Oh, yeah, Sean's going to learn some Linux.
No.
375 amps lead acid. Yeah, you can mix it if you know what you're doing, but as long as you know what's going to happen, because the lithium is going to get cycled, which it can handle, but it's also the lead is also going to drag it down. So
Dinner time. We'll be right back. It's not going to be that long. We're going to
Commercial
eat
break.
fast. Eat fast, so we'll be back. I'll leave the stream running. Phone's
just
probably.
pause it or turn it off.
Yeah. Let's see. How my phone? Oh, I'm still. All right. So yeah, we'll come back here pretty soon. We got 24 people watching.
Yeah.
I'm gonna cut every single one of them off. They're like, Sid's done.
Say we'll restart it. We'll get it later. I don't know that we'll get this running. We probably could if I threw this main board in. I'm curious to see if the no load current this transformer is, because my tests say it's gonna be a lot worse, which I don't like.
All right, we'll take a break from the live streaming for a little bit. We'll come back when we get anything good to show. So, there you go. See ya.